Hey everybody, it's Mr. T. I just wanted you to notice a little halo above my head. It's actually a light in the room, but I was noticing that. Anyway, I'll stand up straight now. Hi, I just wanted to see my safe face first before I go over a couple of word problems. I'll put this link out there in case you want to follow along. Let me share my screen. Let's see, share, full screen share. Okay, where are we? All right, so we're going to do a few problems on this page. I'm going to change these a little bit to match up there's some angles in here that we haven't learned yet. And I'm going to show you we can get a good estimate with the angles that we have. Eventually, we'll figure out, well, what if I actually with this angle? So, part of the issue with most word problems is realizing kind of what the situation is because we are doing things with right triangles right now. Most of these things will be a right triangle. So you start by drawing a right triangle if you don't have a picture drawn for you already. So the idea is you're measuring from the ground up to the top of the tree. You know you are 47 feet from the foot of the tree, and what's called the angle of elevation, which I'm going to circle here, is a term that might comes up. That just means the angle looking up. So the angle looking up is 35 degrees. Now we don't have that on our table that we did in class, but there was one in the book that we're going to use because they had that. And we're supposed to find x. So the idea here is if this is a right triangle, this is always the hypotenuse. If we're going to use that angle, this is the adjacent and this is the opposite. And obviously, if we were going to use this angle, the hypotenuse doesn't move, but the adjacent and opposite swap places. And just as a reminder, that other one is what's called complementary, which means that the 35 and the other one have to add to 90. So that one's going to be 90 minus 35. I'm doing this all with my finger. So that's going to be 55 degrees. So 55 and 35, 90. All adds up to 180. So our triangle's right. Okay, how do we solve this one? Opposite, because I've got one and I'm looking for one. So I'm going to use the one that I have and the one that I'm looking for. And then I'm going to look up the magic number in my table, which from the book was per 0.35. Opposite over adjacent was that 0.70 right there. So that's where I'm going to say, okay, the relationship between those two is 0.7. And this is where, if you're in my class, we often talk about what do I do with that number? You can think, well, I know this is 47. I can tell from the picture this is going to be smaller. So I know I have the opposite. I need the opposite. I have the adjacent with this 47, and I've got the 0.7 over here. And some of you will realize, oh, I just need to make the 47 small. And we have to just realize instead of dividing to make it smaller, we're going to end up multiplying. Although many of you, when you see this, you're going to remember my trick in class of just turning this into a proportion. And then you'll realize, oh, yeah, definitely multiplying these two. And then I'm multiplying these two. So I'm going to do the opposite times 1, which is just 1. Opposite is the 47 times the 0.70, which is just 0.7. I haven't done this yet. Let me do it on my calculator here. 0.7 times 47. I hope 32.9. Now they said round to the nearest foot. So it should be that one right there. Uh, how do I clear my drawings? Oh, do that. Correct. Okay. 33 is correct. Um, all right, now I have to remember how to clear my annotations. This may take me a moment. Oh, trash. Clear all my drawings. Okay. And then I just have to remember how to stop the annotations. All right, so we're going to roll down to the next one. So very similar question, kind of a weird word here, a guy wire. That is just a wire. I mean, this thing is called a guy wire. I think I've sometimes called that a guide wire, but I guess guy wire is the correct way to say it. Something that's helping to hold something up straight. Um, and we happen to know how long it is, and we've staked it to the ground, and we are trying to figure out how far from the foot of the stop sign to the stake. So first of all, I'll have to read this. It could ask how high this is, the BC, or it could ask the distance from here to here. It is asking the distance along the bottom here. So this is what we're looking for. And then relative to our 51, is that opposite, adjacent, or hypotenuse? And you're like, oh, that's adjacent. I'm going to do this with my finger now, opposite. And this is always the hypotenuse. All right. Let's see. Now, I don't have a table with 51 in it. I'm going to change this to 50 because I have a table with that in it. And I'll just know it'll probably be close to one of these answers. But I'm going to use the table I have rather than the table I want. So I'm going to go to our table from class, which this is where he copied it down from. So 50 degrees. Ooh, what am I doing? I am doing, got to think about this. I've got the hypotenuse and I'm trying to find adjacent. So I'm looking for adjacent over hypotenuse for 50 degrees. So now I'm going to go over 50 degrees. Adjacent over hypotenuse is 0.64. Okay, 0.64 and 0.64. And once again, I know I want this number to be smaller than the 8. So you could think about what do you want to do with the 8 and 0.4, or you can just do the equation and say, well, I need the adjacent. I have the hypotenuse. I know the relationship is 0.64. And if I want to turn that into over 1, I can. And I'll just point out that 0.604 over 1 really makes sense because essentially these tables that we have are the tables for triangles where the hypotenuse is 1. Every single thing that's in this table here is effectively like, if my hypotenuse is 1, how long are these sides? And if you think about it that way, this makes sense. If my hypotenuse is 1, all the sides will be less than 1. And then over here, these numbers are different because just because my hypotenuse is 1, it's just a question of, well, I can have an opposite or adjacent that are different sizes, and sometimes the opposite's bigger, which case it's a bigger number. Or if my adjacent is bigger, when I'm dividing by a bigger number, it's a smaller number. That's why those numbers can be anything, but these numbers have to be less than 1 because effectively this table is when hypotenuse is 1. Okay. So I'm gonna cross multiply and solve again. I'm gonna end up multiplying those two. Adjacent times 1 is just adjacent, and 0.64 times 8 is 0.64, oops, 0.64 times 8 is equal to 5.12. Now, I use 50, so I'm guessing it's 5 feet. Let's see if that's right. So I'm gonna hit 5. Yay, got it right. All right. So let's go back to annotate. Let's clear our drawings. Where's the trash bucket? There it is. Clear all drawings. All right, next one. We're going to do a handful of these. Next one. All right, this is important just because of vocabulary, and there's 2 ways to do this. Windy day, 90-foot rope tightly secures a hot air balloon to a stake on the ground. From the balloon, so you're up in the balloon, whee! The angle of depression of the stake is 62 degrees. Angle of depression, so if you think about depression in general, it's like you're maybe looking down because you're depressed. Angle of depression means exactly that. You are up here, you are looking down. So if you draw this line, this is your line of sight, you're looking out on the horizon, and then if you look down, that's the angle of depression. So with these problems, there are 2 ways you can do the problems. One is you can draw a symmetric triangle over here and just realize, oh, this side and this side, the vertical sides are going to be the same, and the horizontal sides are going to be the same. So you can just create a separate triangle and you don't have to do anything. The other is these are parallel lines. The top line and the bottom line are parallel. I'm going to draw little parallel lines on there, which means if that's 62, this angle down here, this alternate interior angle is also 62. So you can use either triangle. I'm going to use the one existing with my little 62 down there. And what are we trying to find? This thing is 90 feet, and we're trying to find the height of the balloon. So the height is over here. So relative to the 62, this is going to be my opposite. This is my adjacent. And my hypotenuse, I know, is 90 feet. So we know, let's see, we have the hypotenuse. We're looking for the opposite. We're looking for the height. And we know we're looking for a 60. So once again, I don't have a 62-degree angle table, at least not yet. So I'm going to use 60, okay? So I'm going to X that out and just pretend that's 60 and just know that, well, it's multiple choice. So if I get an angle that's close, that is probably right. So I'm going to pretend that's 60. Now, if I make this a 60-degree angle, some of you might know the quick way to get this over here, which I'll explain in just a minute, but we're going to do it the way that we traditionally would do like this. So I'm going to go to 60. I'm looking for opposite over hypotenuse. It's 0.87. Go back here, 0.87. And once again, opposite over the 90 feet equals the 0.87. And if I want to make it over 1, once again, going to cross multiply. Going to do that kind of quickly. I'm not even going to write it on the screen. It's going to be something very close to 90. I got 78.3. Now, I'm guessing it's 79. Maybe it's 81 because I didn't use 62. Um, let's just check it and see. Good choice. That is correct. Okay. Um, all right. I'm going to show you the other way you could have done this really quickly. Can I change colors on this thing? Yeah, let me make this purple. If I made this a 60, if I made this 60, this means this is 30. It doesn't look like it, but that means this is half of a equilateral triangle. So if that's 90, this would be 45. And then this over here would be 45 square root 3, because that's our shortcut. And so let's see, I'm going to make sure that's the same number, 45 times, and I'm going to do 1.7. 76.5. Came out slightly differently than I had. Let me try it with square root of 3. Square root of 3 times 45. That came out closer to what we had with the 90 times 0.87. Different way to do it. Okay, let's clean those up. Clear all drawings. All right, do I want to do this one? From a point on the ground, the angle of elevation is 23. It's 1200. I'm not going to do this one. Um, I'm going to ask you very quickly, probably in the chat, to label something, but I'm not going to do that one. Next one, hayloft door. Ted sees a dog on the ground. So once again, Ted's eye is 16 feet above the ground. How many feet must the dog walk? Where's the angle? Oh, the angle of the depression of the dog. Now, they didn't draw anything for you here. So think about what angle of depression means. I'm going to get so angle of depression. Once again, if Ted is looking out, the angle of depression is the amount that he looks down. And so we say that's 40 degrees. So I'm going to try to write 40 in there. Okay. Which means I can use the 40 there. I can make a little right triangle and use this. In fact, I'm going to use this triangle this time. I could make the 40 down here, but I'm going to use the purple triangle over here instead. And so we are trying to figure out the distance to the barn. So the distance to the barn is right here. I mean, I can put the X there or the X here, but it's the same. We've just created a bigger rectangle here. So I'm going to use my upper triangle from the 40. Let's see. Ted's eye is 16 feet above the ground. So, that's 16 over here, which means it's also 16 over here. Once again, because I'm just using my other congruent triangle. And then so I'm trying to find that. So we got opposite, we got adjacent. I don't need the hypotenuse. So I know opposite over adjacent for 40 degrees. I'm going to go to my table for 40 degrees. Opposite over adjacent for 40 degrees. I got it. 0.84. And then once again, so far all the time here, oops, I'm not on the page anymore. We've been multiplying. That's not always going to be the case. Oh, I didn't put a number in there. Here, I'm going to change colors again. Change it back to red. Let's see. I've got oh, no, this one going to be different. So I have this number. That's a 16. That looks like a 9. It's not. It's an adjacent. So we end up getting 0.84 times adjacent. Glad I slowed down. And 16 times 1. So that's just 16. So in this case, because of the setup to start with, there's a division here. I have to divide by 0.84. Divide by 0.84. That cancels to 1. I've got adjacent. And so 16 divided by 0.84 is, oops, my calculator's messing up. Just over 19. So I'm guessing the 19 here is the correct number. It's 19.04. I can make that right, 19.04. So closest foot is 19. Let's just make sure that's right. 19. Great. Okay. Let's see. We're going to do two more, I think. All right. Let me clear all this out. Scroll down. Oops, I can't scroll down if I'm in this thing. Um, let's see. Oh, I might only do one. We already talked about the angle of depression, so you know what that one. I might have you look at that one at the tail end, and I might ask you a question, but you know what angle of depression is now. Okay, last one I'm going to do because I'm probably going a little long here. Shopper is standing on the ground level, 800 feet from the base of a 200-foot tall department store. So first of all, no picture, but I'm like, yeah, we're doing right triangles. This sounds like a right triangle. I'm going to draw a right triangle. Okay, so like this, we're 800 feet from the store. The department building is 250 feet tall. And the question is, what is the angle of elevation, which is this, which coincidentally happens to be the same thing if you were on the top and you were doing, like you're looking out and you're looking down at this person down here, that angle of depression will be the same number. Okay. But we're looking for this one down here. So for this angle that's down here, I'm going to call this A, B, C. Okay. So that's our right angle there. We know that this is adjacent. This is always the hypotenuse. This is opposite, and we're trying to find that number down there. So opposite over adjacent equals something. Okay. Oh, opposite over adjacent equals, not something, equals 250 over 800. 250 over 800. So I plug that in. Opposite over adjacent equals whatever that is. And this is where it's really easy to make a mistake. Okay, that's 0.3125. 0.3, I'm going to just say 0.31. It would be very easy to stop there and think this is 31 degrees, but this is not 31 degrees. This is the ratio between those two sides that will tell me how many degrees that is. Really easy mistake to make there because I know oftentimes I'm just excited I get a number and I forgot to go look at this up. So we're going to go back to our table and see if we can't find 0.31. So we're looking in the opposite over adjacent column. So opposite over adjacent, 0.31. Looks like it's somewhere between 10 and 20 would be right in there. Probably closer to 20, I would guess, but I don't know for sure. So let's see what are our choices back here. Our choices back here are, ooh, now, those are both good choices. And so there's no way for me to know for sure without a better table. I'm going to check one other table. I'm also going to show you one other thing. Let's just go look at the table from the book. Table from the book was this, and there's a reason I'm looking at this. I don't think it's going to help us. See, 25 degrees is the closest we're going to get. So this doesn't help us because we're actually looking for something where this number opposite over adjacent is up here somewhere. It's 0.31. So this doesn't help us other than I know it's less than 25 degrees. I want to point out in the book for some reason, they put adjacent over hypotenuse in the first column and opposite over hypotenuse in the second column. I don't do it that way on our worksheet, and there's a reason. And I'm hoping I did not mess up our thing earlier in class when I grabbed the number for that 30. I might have grabbed the wrong one because I'm so used to doing those. I'll correct it in post edits if I made a mistake there. Anyway, that doesn't help us. What would help us is actually a table with more numbers. So let's see if we don't have a table with more numbers here, which I think we do. More detailed. More detailed. We're looking for 0.31, 0.31, 0.31, 0.31. Looks like it's very close to between 17 and 18 degrees. It's definitely not 19 degrees, which I think was so I think it's closer to 17 than, whoa, I think it's closer to 17. That's a hard choice. We're going to choose 17 and see if we're right. Go back to it. Let me clear my annotations. Oh, let me just do that. 17. Correct. Yay. All right. I may have you take a look at this last one. I'll give you the link if you want to look at the last three here. You can try it yourself. But thanks for listening. I think this one went on just a tad bit longer than I had planned. How do I stop recording? Oh. Oh, I thought I stopped recording. I didn't. How the heck do I stop recording? Where is that? Stop share. And I'll cut this in post. Stop. Ciao.